Let's talk about optimization. In this video, I'm going to do the solution to number 1 on our worksheet. And we'll start off by just remembering the structure of optimization problems that we talked about in class on Thursday. So in number 1, it says find two positive numbers whose product is 200 and whose sum is a minimum. So I have two vocab words here. I think I said constraint in class and objective function. I may not have used those words for. But these are the two big equations that are involved in an optimization problem. So the objective function is the fancy phrase for the quantity that you actually want to maximize or minimize. If you want to find it's either max or min. The objective function is like the function that you're actually working with. It's the one whose derivative you're taking and so on. The constraint is the extra piece of information that's always there. There's always some extra way to tie together essentially the two inputs you have here. And the constraint is what you use to make the objective function a function of one variable instead of two. Okay, so let's see how these terms apply to this problem. They say find two positive numbers. I don't have a diagram to draw here, but what I should start by doing is naming these two positive numbers. So let's say I have two positive numbers. I'll call them x and y, but any two letters are fine. Because they're saying they're positive, I do happen to know that x is greater than 0 and y is greater than 0. They say their product is 200. Product means they're being multiplied. So we know that x times y equals 200. And they want to find the minimum sum between those two numbers. So sum is adding, product times sum is plus. So we want to find the minimum sum. That's going to be the objective function. So I'll call it s of x to be the sum function, or actually, why don't I just call it sum for now, because it's going to be a function of x and y. So we'll say s equals x plus y, and we want to find the minimum of this. So this xy equals 200. This is the constraint. It has kind of a fixed value in it where like they have to have this relationship. It's not something that we're trying to maximize or minimize. So this constraint is what we're going to use to turn this into an equation of either just x or just y. In this one, you can pick either x or y and finish off the problem to the same answer. Sometimes it's a lot easier like to solve this for one variable as opposed to the other, which we'll see later on in the worksheet. But in this one, either one is fine. Okay, so I'll take my constraint equation and solve it for one of the variables. Again, it's just as easy to solve for y as for x. I'll solve it for y. And I get this relationship that y equals 200 divided by x. And that's what I'm going to plug in for y in my objective function right here. So now we have s of x. Now it's a function of x. Is x plus this 200 divided by x. So now from here, I can just find the location of the global minimum of this function, and that's going to lead me to my answer. And it kind of works as like a normal minimum problem from here on out. We do technically want the global minimum within this kind of extra piece of information, so we can ignore any negative input. All right, so I'm going to start by finding the critical numbers, and then I'm going to use, we have three options: first derivative test, second derivative test, or closed interval method. I'm going to use the first derivative test. Okay, so to find the critical numbers, I'll compute the derivative. X's derivative is 1. 200 over x is the same as 200x to the negative 1. So when I take its derivative, I get 200 times negative 1x to the negative 2, which is 1 minus 200 over x squared. All right, so you may notice in the search for critical numbers that 0 is a number we can't plug into the derivative, but 0 is being excluded anyways here. So we're going to test numbers strictly greater than 0. So we can kind of acknowledge that it is a critical number, although it's not in the domain of the function anyways, so we're going to kind of ignore it. So what we're really going to do is set this equal to 0 and solve for x. I'll add this term to both sides. Multiply both sides times x squared. And then plus or minus square root both sides. And I have two critical numbers, the positive square root of 200 and the negative square root of 200. Since I don't have a calculator, I'm going to leave it in that format. And I'm also going to notice that because we said in the beginning that the numbers had to be positive, we're going to kind of toss the negative square root of 200 and just focus on positive root of 200. It's probably our answer, but if we stop here, we have an incomplete solution. We want to test it. So I'll label this as the check. And I don't mean check as like an extra check answer, like this literally has to be part of the problem. Right, so I'm going to set up a number line here for s prime, and I'm going to mark root of 200. And you'll notice instead of an arrow on the left side here, I have a parenthesis to mark 0 being the end of the test points here. So this is the domain, like the relevant domain. Because root 200 is the only critical number in the relevant domain, this will be a minimum as long as we can see s go down and then up here. All right, so we're going to put in test numbers into s prime. I'm going to use this version of s prime right here because I find it the most usable, but anything along the way like this version also would have worked. All right, so I need a number less than root 200 but greater than 0. Don't overthink it. Let's plug in like 1. So s prime of 1 puts a 1 right here. I have 1 minus 200, that's negative. And we know we're 0 here. A number bigger than root 200, let's say just regular 200. So if we plug in regular 200 here and square it, this is a fraction, right? Because it's 200 over a really, really big number. So we have 1 minus the small fraction, that'll come out positive. And this number line is showing me exactly what I wanted to see. S prime is negative then positive, which means S was decreasing and then increasing. So we have a minimum at this X value. All right, so the question told us to find two positive numbers with this property. I know X is root 200. So I'm just going to go back and find the matching Y value. There's a bunch of different places that you could do it. I like to go back to what I kind of boxed in here when we solved the constraint for Y. That's the quickest connection between X and Y. All right, so when X equals root 200, Y equals 200 divided by X. So we have 200 over root 200, which actually just gives you another root 200. So my answer is X equals root 200. Y also equals root 200. And that's my solution.